Hello everyone, in this video I'm going to solve problem 6 of chapter 8. The automobile has a mass of 2 megagram and center of mass at G. Determine the towing force F required to remove the car. Both the front and rear brakes are locked. Assume that the coefficient of friction is 0.3. So this is a type 2 friction problem because we know the surfaces that we are having an impending motion. So the first step is to draw the free body diagram. So I'm not going to draw the whole car. I just draw the car as a box. And then here at B, because the car is moving in this direction, the friction force is acting the opposite. Same thing at A. So here I have FB and NB. Also at point G, I have the weight of the car, which is 2 megagram or 2000 kilogram. And then at A, I have NA as well as FA. Also, I have the force, the towing force acting here is acting at an angle 30 degrees. It has vertical and horizontal component. So F sine 30 and F cosine 30. I'm going to assume X and Y my coordinate system. So if we list our unknown, we'll see we have MB, FB, NA, FA, and force, the towing force. So I have 5 unknowns, and in 2D equilibrium, I have 3 equilibrium equations. So I need 2 more equations, and I get those equations by relating FB and MB. I know there is impending motion or is a sliding, so FB is simply mu MB. So I get 2 more equations, or we can think of it as we are removing 2 unknown. Now I have 3 equations. I can write 3 equilibrium equations, and I have 3 unknowns, and I can solve for those unknown. But let's draw the dimension here. Here is 1.5 meter. This would be 1 meter, and the distance between the force would be 0.75 meter. And also we have distance of 0.3. So I'm going to write my equilibrium equation. Summation of forces in x direction equals 0. Therefore, I have negative F cosine 30. And I have my 2 friction forces, FA and FB. So plus FA plus FB equals 0. Or I could factor these 2 and then write 0.3 NA plus MB. Because this is 0.3. So FA and FB are simply 0.3 NA, 0.3 MB. The friction coefficient is the same between the tires and the ground. This is the same ground and the same tire. So I have 3 unknowns in this equation, and I can't solve it. I need to write my subsequent equation. Summation of forces in Y. I have the normal forces, the vertical component of force, and the weight, which gives me 19,620 Newton. And now I need to write my moment equation. I can write moment equation about any point. I'm going to write it about point A, so I can get rid of two forces. I'm going to assume counterclockwise to be positive. So the weight is creating a clockwise moment, so it has a negative moment. The magnitude is 19,620. The moment arm is 1. MB is creating a counterclockwise moment about point A. MB is rotating it in a counterclockwise motion, so it's a positive. and the moment arm is 1.5 plus 1, so 2.5. The horizontal component is going to create a positive moment, so F cosine 30 would be positive, the moment arm would be 0.3, and the vertical component is creating a negative moment. The magnitude is F sine 30, and the moment arm is 0.75 equals 0. So if we look at these, we have 3 equations and 3 unknown, so we can solve for our unknown. So the force F would be 5.8 kilonewton, and A would be 8.6 kilonewton, and MB 8.11 kilonewton. So the problem was only asking for force F, but once we find force F, then the other unknown will be determined as well. So looking at the problem, it appeared that we have 5 unknown, but we have relation between friction force and the normal force, and they are related by coefficient of friction, this 0.3 value.